Hello, welcome, and thank you for joining us for Zoom into the Void with the Danville Science Center, presented by Dynactici Associates. I am Ben Wright, Immersive Experiences Coordinator here at the Danville Science Center. And in just a brief moment, you will be joining me as I highlight some of the skybound activities for the month of July 2020. This is our first virtual online interstellar discussion being broadcast to Facebook Live in addition to Zoom, and we welcome all of our friends joining us on Facebook. Those of you who are again zooming into the void are reminded that throughout our discussion, you are invited to submit your questions directly to me using the chat with host feature there in Zoom. I will attempt to go back at the end of my presentation and answer some of those questions. But we begin now, as we always do, directly inside of the free-to-use sky viewing software, Stellarium. You can see in the corner that it is just a few moments past noon, and we are here outside of the Danville Science Center, outside of our Digital Dome Theater. Stepping back a few steps, we can see that we are facing the southern sky. East is to our left, and west is to our right. Gazing upward, we can already spot a particular body in our sky, sharing its light with the sun occupying our horizon. We can spot our waning crescent moon. The moon is positioned to make an appearance during the day. We can sometimes see the moon during the day because it reflects the sun's bright light back at us. We can't see the light of other stars because the light they produce is not nearly as bright as our sun. We have to wait until just after sunset to see some of those. Doing so, we can actually spot an arrangement of stars named specifically for this time of year. Turning our gaze eastward, we can find the three bright stars, Altair, Deneb, and Vega. Each of these stars belongs to their own constellation: Aquila the eagle, Cygnus the swan, and Lyra the harp. But collectively, it doesn't take much imagination to see that if we drew a line connecting these three stars, we'd get a shape. This shape is known as the summer triangle. The summer triangle is an asterism. Asterisms are recognizable patterns of stars that are not officially recognized as constellations. There are some 88 different universally recognized constellations, but there are thousands of asterisms. Just like one famous asterism can be found in Ursa Major, the Great Bear, that of the Big Dipper. We can spot another asterism in the night sky if we turn our gaze downward toward the horizon within the arrangement of the constellation Sagittarius the Archer. If you look very carefully, you may spot in the center an outline of a teapot. Some folks, when they see this kettle, picture steam rising from its spout. Others see this smear in the sky and think it looks like spilt milk. It is actually something far greater. You are seeing the core of our own galaxy, the mighty Milky Way. The Milky Way reaches prominent visibility above the horizon this month. Best viewed around midnight, though visible anytime after dusk, we can see the beautiful dust lanes, nebulas, and star clusters of our galaxy with the naked eye. There is believed to be somewhere between 200 billion to 2 trillion galaxies in the observable universe, each containing billions of stars. The Milky Way is categorized as a spiral galaxy given its unique shape. Returning back to the boundaries of Sagittarius, we can spot another object comparatively small to a galaxy, but still incredibly large. I'm talking about the largest planet in our solar system, Jupiter. Jupiter is so big that if we combined all the other planets into one, Jupiter would still be twice as large. It reached opposition last night and remains particularly bright this evening. Unlike the inner planets of Mercury, Venus, Earth, and Mars, Jupiter's surface is composed of gases rather than solid Earth. These gases swirling around the planet give Jupiter its distinctive look. Jupiter's most prominent feature is the Great Red Spot, a massive hurricane-like storm the size of 3 Earths that has been observed at least since the year 1878. Jupiter's massive size means it also has a massive effect on the fabric of space-time it occupies. The planet's huge gravitational field pulls in over 70 different moons, second in number only to Saturn. One of Jupiter's moons, the icy Europa, is of interest due to its potential to house life. The smallest of the 4 Galilean moons, Europa, is 90% the size of Earth's moon. Its surface, covered with ice, would make it far brighter if in the same position, however, almost 6 times as bright. The red cracks running across Europa's surface may be composed of nutritious salts and are sulfur. Its thin atmosphere contains oxygen, largely contributed by water plumes pushing up and out water vapor. Below its icy surface may be a massive ocean of liquid water. Astrobiologists are currently developing spacecraft to search for life in this water. Spacecraft like BRUI. BRUI stands for Buoyant Rover for Under Ice Exploration. As its name suggests, BRUI is designed to float underneath the ice. Using its pair of teeth-covered wheels, it crawls beneath the icy surface. It intentionally moves slowly so as to not disturb any to-be-discovered microscopic life. NASA scientists have tested BRUI in parts of Alaska and the Arctic in preparation for its future search for life on Europa. The search for alien life continues much closer to home. The Perseverance rover is scheduled to launch aboard an Atlas V rocket to the surface of Mars on the 30th of this month. Perseverance, the size of a car and similar in appearance to the Curiosity rover currently exploring Mars, has one main mission: to drill into the Martian soil and collect samples. Those samples to be eventually returned to Earth on future missions. Samples will be collected at a location near Jezeros's crater, a giant basin that at one time may have contained a lake-sized body of water and that may now contain signs of microbial life. Perseverance has 23 cameras and 2 microphones. Following its arrival to Mars in February, Earthlings will be able to see and hear the Rust planet like never before. Speaking of things never before seen, we can't go without discussing the newly discovered comet C2020F3, better known as Neowise. Discovered back in March, Neowise is estimated to be around 3 miles across and is the brightest comet visible to the Northern Hemisphere since 1997's Hale-Bopp comet. Comets are icy bodies of frozen gas that orbit the sun. When their period nears the sun, comets warm up, releasing their gases in a visible atmosphere known as a coma. The coma trails through the sky as the comet's tail. Neowise can be seen just after sunset in tonight's sky, and for about another week, if we rewind back to just after sunset and turn our gaze from the east to the northwest, we can find Neowise within the constellation of Ursa Major, the Great Bear, just below the asterism of the Big Dipper. Neowise is named after the Near-Earth Objects Wide Field Infrared Survey explorer, Neowise, that discovered it back in March. That gives us a brief look at some of the objects we'll see in tonight's sky. Now we turn it back over to you as I attempt to answer some of your questions to dive us even further into July. So we begin with a question from Phil. How long will we be able to see the Neowise comet? Neowise will be around for at least another week or so. Following about July 22nd, it will be too close to the sun for us to really see it. Its light will be competing with the light of the sun when we otherwise would be able to view it. Tonight is a decent time to see it. You can also see it early in the morning, just before dawn, just before the sun comes up. Rather than looking in the northwest sky, you will need to look in the northeast. Next week will also give a particularly good view of Neowise early in the morning, as our moon will reach a new moon phase on the 20th, giving us plenty of dark skies to see the bright comet. Our next question is from Sarah. Sarah says, what does it mean to be in opposition? You say Jupiter was in opposition. What does that mean? Opposition means that a planet, rather, is considered in opposition when it is opposite the sun from the Earth's perspective. So it is if it goes sun, Earth, planet. This allows the planet to be most directly in sunlight from our perspective. You may be thinking about an eclipse. How come the Earth doesn't block the light of the sun on the planet? Well, the sun's big. The sun is massively big. It's about 1 million times larger than the Earth. A planet like Jupiter is 1/10 the size of the sun, but still incredibly large, at 100,000 times larger than our own planet. The Earth will not block that sunlight from reaching Jupiter, but we will be able to see some of that light bouncing back from the planet's surface. Jupiter is pretty far away from the sun too, at some 483 million miles. In fact, it takes light from Jupiter 43 minutes to reach our planet. So the planet you see tonight will actually be what the planet looked like about an hour before you see it, during the time it takes light to travel. So Jupiter can be at opposition. Just about any planet can be at opposition from our perspective. It varies with the planet's period or revolution around the sun for when exactly that will happen. Jupiter takes 12 Earth years to orbit around the sun, but there are different times in its orbit where we line up perfectly for it to be at opposition and for us to see it looking mighty bright. You may have also noticed, if we fast forward back a little bit into our evening, another bright object right next to Jupiter that is its sister planet, Saturn, the second largest planet in our system that has 10 more moons than Jupiter, but that can also be seen in tonight's sky and for much of the month as well. Jim asks, when can we expect for humans to get on Mars? Is it a realistic expectation? NASA administrators, as well as our own government, are anticipating humans are planning for a crewed mission to Mars by the year 2030. A lot of that determines on what we discover with current spacecraft exploring Mars. What we find with Perseverance will be helpful, but it is not the only spacecraft that is trying to dig into Mars. Right now, the InSight lander that has been on the Martian surface since 2018 also has a drill. Its main mission is to discover Martian weather. It is trying to drill into the surface of Mars to see its temperature much lower. It also, within the planet, it also has a seismograph on it to measure Mars quakes, similar to earthquakes, but on Mars. That will help us prepare for what it could be like once humans reach the red planet. In addition to knowing what weather will be like once we get there, we have to decide where we're gonna land. Perseverance landing near Jezro's crater is helpful. In addition to the cameras and other tools on Perseverance, there will be a small helicopter about the size of a drone, but with a central propeller, thus a helicopter, that will be making trips from Perseverance out and back to look for other good locations for humans to land on Mars. Landing on Mars and returning to Moon are currently the two main missions that NASA is looking at. Brandon asks, How hot is Mars? Mars is much colder than our planet. It's further away from the sun, but what's even more part of its cooling is the fact that Mars is covered in layers of iron oxide dust. That's why we call it the rust planet. Massive storms on Mars can stir up this dust, covering the sky with debris, so much so that it can actually block sunlight, making it even more cold and more of a hazardous environment to be on. In addition to the extreme weather, the extreme temperature, and the scarcity of items on Mars, something else that humans have to worry about is radiation from the sun. Mars's atmosphere is much thinner than ours on Earth, and so that's something we have to consider in looking at humans' exploration of our red neighbor. And then finally, Caitlin asks, when might Bruy or other probes be sent to Europa? That depends. We really don't know yet. It depends on continued testing. The footage you saw there of Bruy comes from 2012 when the spacecraft is being tested in Alaska, but it's being driven remotely by astrobiologists in Florida using satellites. Unlike some of the other spacecraft on planet like Mars, say like Curiosity, Perseverance, InSight, that are largely controlled, they are automated, they're able to sort of, kinda draw themselves and make some decisions as they are discovering. Craft like Bruy will be completely remotely driven, meaning someone here on Earth will be guiding Bruy during exploration on moons like Europa or even moons of Saturn like Enceladus. That's the big challenge now, is how do we extend that remote control? It's like a really, really, really far away remote control car. We've got to keep that signal solid so that we can move the craft, but also get footage back so that we can see what we are trying to discover. It will hopefully be in my lifetime. If not, then yours. But you'll be sure that as these advances develop, we'll be with you along the way to share them with you here at the Danville Science Center. We thank you again for joining us here as part of today's virtual online interstellar discussion with the Danville Science Center, presented by Dynactic Associates. We hope that you join us next month at the beginning of August, when we celebrate some of the objects we can see in August sky. Until that time, we hope that you stay healthy, still stay safe, and as always, stay curious. Thank you and have a wonderful day. Bye.